We are going to hide these designators, we don't need them now. So go to filter and write is designator, enter, apply, go to PCB inspector, hide. Go to PCB, clear the selection. Now I will split the window so we can see PCB and schematic here. So I go click here, we see the schematic here. And check if you have this setting, tools, cross select mode, it is selected. When you click to PCB, same, tools, cross select mode. So what is happening, when I select a component here, it selects also in PCB. If I select a component in PCB, it selects in the schematic, because we are going to use it. First we will start with this biggest component in the middle, and we will use special command for placing the components. Click here, click into your PCB, go to tools, component placement, reposition selected components. It automatically moves the component which we selected. And press L on your keyboard, you change the layers. Now it is on the top. We would like to have it on the bottom, so press L. And I will place it somewhere here. In case you can't see some of these windows, for example filter, inspector, you will find them here. Click on the PCB. Here is PCB inspector, PCB filter. So you can always switch them on here. And for placement we will use grid which is like 0.1 millimeter. We now can continue with other components. Just to make it nicer, I will switch off these nets. View, connections, hide all. And to make the placement a little bit easier, I will make a shortcut here for the placement. It's component placement, reposition selected components. I will place it, the button here. Okay. Start with these two components. Click, shift, click, hold the shift down and then click. Go to PCB, reposition selected components, L, L. And here is one thing what we are going to fix. As you can see, when I close components very close to each other, there is error again. They are green. So there is a rule, design rules, component clearance, which we will set to be 0.1 again. Okay, now we can go closer. Same for the other side. Click, press shift, hold it down, click, you can release the shift, click to PCB, reposition selected components, L, L. Press spacebar, you rotate the component. Next, these three, hold shift down, click to PCB, L, it will go here, this one will go here, this one here, this one goes here, okay. Now let's have a look on this divider. It will be here. You see there is FB1, it goes there. Okay. Here is the other divider. The pull-ups. Temporarily I will place them here just to see how much space we need. These two pull-ups. Now this power part, first I will just select this. It goes to pin number 6. Here is the pin number 6. You can see when I hold cursor on a pin, it will make the white outline, so I see where it is connected. And pin 19. Here. There are some other resistors close to pin 19, this one and this one. Okay. This capacitor close to pin 3. Here is pin 3. And pin 7. Oops. Good. On the top we will place the transistors, inductors and the big capacitors. So let's have a look where the transistor is connected. Okay, so this one should go somewhere here. This other one will go somewhere here. Inductor here. Capacitor. Perfect. It actually remembers the order when you are selecting more components. So it's very useful. This capacitor needs to go close to input voltage here, and also this way. Don't worry about it, doesn't look nice now. We will be making some optimization. And almost done. Almost done. These two. We missed this component. Which one it is? We can go here, click here, and select the pin. It will select the pin. It's this one. It will go temporarily somewhere here. Good. To make it more comfortable to work with your PCB, we will create layer sets. Layer set is a kind of view where you enable just some layers which you would like to see. For example, for top layer, we would like to see only the layer where is the copper and the layer where is the outline around the components. So when you look on your PCB, basically the white color around the components. Here in our PCB, it is this yellow, and the copper is the red one. So I click here, this is the place where you can set it. ls board layer set, new set, empty, top. I will enable top layer and top overlay. I will create also bottom layer set, bottom layer, bottom overlay, and top and bottom. Top and bottom. All these four. Close. What happened? Now when you click on this small button ls, see, here are the layer sets which we have just created. When I select top, I see only the top layer and the component outline. When I click on the bottom, I see only the bottom layer and the component outline, top and bottom. Placement is very important. So what I will do, I will drag and drop this PCB, and we have now peak window, so we can see it. I will disable these dots from the grid. Do you know how to do it? Do you remember? Snap, grids. Do not draw. Do not draw. I will go on the bottom layer, and this is the place where we will start. What I will also use is go with your cursor on a net, for example this one, press Ctrl, hold it down and click. It will highlight the net where the cursor was located or placed. When you press square brackets, you can change intensity. This is what I will be using quite a lot. And because the proper placement may take some time, I will try to do it as fast as possible. I will start here. This goes here, this goes here, here, here. Okay. Ground. This one. This big capacitor I will place somewhere here. I will leave space going with this 5 volt here. And good. Now the easiest way to see how good the placement is or how close the placement is, select all of them and see. Okay, now it looks it is in the middle. Good. Let's check this line. We can go closer. Okay. This one can go here. With this one we can go here. Good. Here, ground. We need to place the LDO. Here this capacitor. So this pin goes here, this pin goes here, this one goes here, this has to go here, goes here and there. Okay. Okay. I will move this a little bit here, and what I will do, I will actually place these resistors better way. I can connect these together. This one. Connect also these together. This will need to go this way, so this will need to go this way. Do you understand what I'm doing? I'm imagining, I can imagine how I will do the layout. From here I will go here. From here I will go here, and then somehow this way connected here. Okay. This one goes here, so again with this I can go somewhere here. This one we place here. Good. This one is ground. This one I can place anywhere. This one I need to place here. Okay, good. Just double checking. Before we actually start drawing the tracks, doing the layout, we will set up some basic rules for the layout. These rules are specified by capability of your PCB manufacturer. So one of the things which you need to check with your PCB manufacturer is what is the minimum clearance. It is the space between two tracks, the isolation. I will use 0.15, and you need to check what is the minimum width what they can make. Again, I will use 0.15, and for the maximum, let's say 10 millimeters. Okay, and now we can do some preliminary things based on our placement. Okay, good. This is just to see how good our placement is, if we can fit everything correctly. Okay, I think I see potential issue. This. So we need to move this a little bit further. Maybe better move it like here. So we have also space for this one. And we need some space also for this one. Again, we need to move this a little bit. So we can go good. For this, maybe the best will be have a plane. We need to connect few other things. What is ground? This is ground. To make it more visible, I will assign a color to ground. Ground, right click, change color. I will use dark blue. Press F5. You can switch on the color overdrive, or F5 it will disappear. So for example, if you select color for more nets, you can switch it off or switch on F5. You would like to see it. You would like to see what paths are ground. Okay. For this demonstration, I will use 6-layer PCB just to show you how you can design board with more than 2 layers. So what I will do, press right click, options, layer stack manager. See, currently we have only 2 layers. I will add one ground plane, then I will add 2 layers and another ground plane. 1, 2, 3, 4, 5, 6. Top layer I will call L1. This one I will call L2 and assign it to ground. Oops. L3, L4, L5, ground, L6. So what we can do, we can actually add the ground bias, and we will create some planes on this layer 3, layer 4, and the rest of the signals which are missing. I will improve the placement on the top layer, so select top, right click, snap grid. For the placement, for this big placement, I will use bigger grid, 1 mm. I know this capacitor should be close to this pin, So I will close it here, I will place it here. This inductor should be closed here, and this capacitor close here. Okay, nice. Same way I will do the placement here. Good. This is what, 24. I will move it a little bit. 5, 1, 2, 3. 23. Nice. Here. Good. What is the position? 30. This one is 20. 4. Let's move it to be 5. 5. These are 46, so let's move it 5 millimeters from the edge. Nice. We'll move this a little bit closer. Press arrows, you can move it just one step. And I will change the grid back to 0.1. Now, important part. We need to place vias. First, let's set a default via. Default via you can set here. Preferences, DXP preferences, PCB editor, default via, and ask your PCB manufacturers what is the minimum via they can make. As you can see, I use 0.2 and that's the hole, and 0.45 is the ring around the hole. Also, I normally mask the vias. You have two options. You can specify it like this one, for example, or you can force tenting on the top and bottom. It will mask the via. Mask, it means there will be the green color on the vias. Also, we need to check one rule. The rule is this routing style for vias, because we use the hole 0.2, so it would fail here. So I put here 0.1, 0.2, maximum 10 millimeters. That's not really important. The ring is minimum 0.4. We use maximum, let's say 10, and we use 0.45. And also check the hole size. Minimum, maximum 10 millimeters. Okay. We can start placing the vias on the unconnected nets. Let's have a look here. We can't place vias here because here is the path. So I will move these components. These are just power OK signals, so it's not really important where exactly they are placed. I I will connect it like here. Because this is power, I would use a little bit wider track. So start drawing and press tab. We can change the width to 0.3, for example. Okay. Double click and then right button on your mouse. Here are the vias. Place via. And I will click here, press shift down. I will select also the via, Control C, click here. This is the position. Then when I press V, it will be snapped. See? If I press Control C and I click here, then this point will be the position where the cursor is when I press Control V. See? But this is better position. So Control C, Control V, and I will place it here, also here, here. Good. Space bar to rotate. This one we can delete, press delete. Can make it even smaller. And if you want to delete more segments, select first one and press backspace. I will connect also this one. Good. Now we can go from the pin 1 and connect rest of the tracks. I change width to be 0.2 because it was too big. You could see the copper was somewhere here. I can show you again. Press Ctrl Z, you go back. So start, press tab, 0.3. See the copper here, it goes closer to the other pin. So I change it to 0.2 and it's now correct. One, two, three. Here we can place a wire and make it. We will make it then a little bit wider later, but you can do it also now. Start routing, press tab, 0.3. That's too much, so 0.2 and 0.2. Good. This one needs to be connected with this one, so I will place a wire here. Okay, and we will connect it on layer 2. So I will show signal layers. I go on layer 3. I go on layer 3 and I will connect it here. I go back to the bottom. Here we have ground. Zero point 2. This one is unconnected. 1.5. It will be connected here. Okay, this one, it's okay, it's okay, this one is power, okay, it needs to be connected with this one. Zero 0.15. The next pin, okay, this goes nowhere. This one. I will move this a little bit, so just click and drag. I will connect it to this one. Shift. I will copy this track because I know it goes also here and here, just to make it faster. Go on layer 3, connect together. Next one goes here. Preliminary, I will just connect it like here. Later I will draw polygon, so copper, full copper around this path. At this moment I just want to be sure I can connect everything and I see how it looks, so I can optimize it. Because layout for switching power supply is very important. Goes nowhere, this one goes here. Layer 3. Okay. Ground. Oh, this is not nice. I will redraw it. Okay. Again, this is not nice. I will then improve the layout as I already said. Good. This goes here. So I need some space. On layer 3. Connect this one. I will still leave it unconnected because I don't know what other connections will be here like. Goes nowhere. This is ground. It's connected here. Again, just temporary connection. There will be plane or polygon. Good. Good. I can now show all the connections. So we see what still needs to be connected. Now I'm going to connect everything. And I will then explain you what connections are important, and we will improve them together. Because some of these are not really how they should be. For example, big capacitors, they should have more vias. I will explain. Because there are big currents. And one via can carry only limited current. So for our power supply, which support like 5 amps, for example, one via is not enough. On layer 4, I will connect this. I will actually make a big plane on layer 4. But currently I use only this temporary connection, because if I draw a plane, here I could draw the plane, but in your project, if you draw plane too soon, it's hard to work with, because it will be covering all the tracks what are below the plane. And also when you place, for example, a via, there will be violation all the time. You need to refresh all the time the plane. So it's much easier if you just draw the tracks first and do the planes and polygons on the end of your layout. Let's connect these grounds. Again, these are transistors. Here will be big current flowing, so we will improve it. Same, here is capacitor with big current. We will draw small planes everywhere. You need to always think ahead how you use your layers. I will rotate this capacitor. It would be much better if this goes like here rather than around. So I go and do it like this. Good. We can actually move it even closer to the inductor, and same here. Does it look same? The 17.2 is the X position. 17.2. You know, just to make it look same and nice. I need to move also this. If you want to move something which is very difficult to move, use this. Good. So now I can go here and here and connect this to ground. Good. I will redraw this one. Good. Only few unconnected nets. You can actually, there are some commands which, for example, press plus, minus, you change layers, and the vias can be placed. I just like to have full control over tracks and vias. Sometimes it may be a little bit time consuming, but it's just the way you prefer to work with. So you may want to have a look on some ways how you can speed up, improve, or make the design the way you really like. You know, I mean the way how you work with the Altium designer, because there are a lot of options how you can do one thing. The best, you need to choose the best one which fits exactly to the way you like to work. Still this one. Shift S. Only these grounds are still unconnected. Here I need to move these tracks here. So I have place for via. And here. Here you may want to place more vias because it also will carry some heat out from the chip. You see there are violations. So I just go on each layer now and I fix the violations. I redraw the tracks. Here. I still see there are some errors, like here is green, but I'll show you how you can check what's wrong and how to fix it. See, it says here some errors. First, this one, layer 4 and via. It's not very visible for difficult designs. This is not very visible, so much better way to do it is PCB rules and violations. And you can go here one by one and look here. Nothing. Here is an error. So you double click, you say jump and highlight. It is much better. You see it here. It is much better than if you use this one and click here. So I will redraw it. Good, the error is gone. Test point. We don't use test points. I will disable these. This one, jump, highlight. Okay, delete. Here are all the rules. Test point, thermal. We will fix this before we finish the layout. Important is we enable these unrouted nets and we are sure everything is routed perfectly. So the unrouted nets are 0.